So hello everyone, I'm Dee, a second-year PhD student studying in University of Sydney. I'm working with Scott and Julia. I'm very glad to present my work in the ASTRO 3D virtual sense meeting in such a difficult time. My topic is spatial resolving galaxy environmental quenching in the SAMI Galaxy Survey. To start, I'm going to give a brief background introduction. So a physical understanding of the star formation within galaxies remains an important goal for galaxy evolution studies. And large galaxy surveys have already shown the galaxy quenching depends both on stellar mass and environment. So I'm using the full SAMI IFU to analyze the distribution of the star formation in each galaxy to where is the star formation quenching happening, to compare with the environmental density, and to see how fast is the quenching happened by analyzing different stellar population indicators. So first, I would like to show the distribution of star formation region in each galaxy. I'm using the concentration index, which is the ratio of R50 of H alpha to R50 of the continuum map. So this index indicates the extent of ongoing star formation to previous star formation. The larger concentration index means it has an extended star formation region in this galaxy. And here I'm showing the SDSS image of this galaxy. And the blue circle shows the SAMI IFU region. And the second one is the H alpha flux map. The two other mean radial profile, which shows how to create the concentration index. We also correct the AGN contamination for the liner or AGN-like galaxies. I'm using the BPT diagram of the emission line ratio diagram. And here is the liners and composite galaxy and star formation region. I'm not showing this in detail, but the right four plot shows one example of an AGN-like galaxy. So the top right one is the AGN contributed ratio from blue to 100% AGN and right to 0% AGN. With this ratio times the original H alpha flux, we can get an AGN corrected H alpha flux. The AGN contamination correction won't change the concentration index significantly because the AGN liners are usually quite faint and it has an extended star formation region. Then let's compare where is the quenching happening. This plot shows the concentration index as a function of stellar mass in different environmental density, color-coded by the specific star formation rate. From left to right is the N-grouped galaxies, galaxies in low halo mass group, high halo mass group, and cluster. For the y-axis, I'm using the log scale. So when the scatters is above the 0 reference line, it means it has an extended star formation. When it's beneath the 0 reference line, it has a concentrated, centrally concentrated star formation. We can see from left to right, galaxies in higher environmental density tends to have more concentrated star formation. To quantify this concentration index in different environmental density, I'm using a normalized histogram. I did the KS test for the concentration index for the ungrouped and low halo mass groups versus the high halo mass group and cluster. We can see the p-value is slightly larger than 0.05, which indicates the distribution of concentration index in the N-grouped galaxies and low halo mass groups don't have significant difference. So I will combine those two samples together to create a histogram on the right. So the green line is the N-grouped and galaxies in low halo mass group, red for the galaxies in high halo mass group, and yellow for the cluster. Again, the purple line is the 0 reference line. And we can see from the plot, there's a tail character in high halo mass group and clusters, which also emphasize galaxies have more concentrated star formation region in higher environmental density. We also like to know when is the quenching happening, as well as how fast is the quenching happened. So to see the ages of these galaxies, we can use several color parameters like J-I color and U-R. And here I'm plotting the J-I color versus the stellar mass color coded by the concentration index. And this is in log scale. And larger J-I color means older stellar populations. From the circle shows and in high halo mass group and cluster, we can see galaxies have centrally concentrated star formation have rather J-I color, which is an evidence of an aging population. To see how fast is the quenching happened, we're gonna use the DN4000 index and H delta absorption line equivalent wise as indicators of the stellar population. Here I'm showing again a SDSS image with circle shows the SAMI AFU region, as well as the H delta versus DN4000, color coded by the radius in pixel, as well as the DN4000 and H delta map in sector binning. I'm also showing the DN4000 slope and H delta slope. For this galaxy is a quite extended star formation galaxy. And from the gradient, we can see the galaxies has an older center with younger outskirts. Younger outskirts, it just shows the mass-dominated quenching. And here we got a DN4000 gradient, H delta gradient versus stellar mass, color-coded by the concentration index with 0 reference line. For we know galaxies in higher density region have centrally concentrated star formation. So the DN4000 gradient will be larger than 0 in the high halo mass group and cluster. And the top row shows what we expected. For a centrally concentrated star formation galaxy, if the galaxies have fast quenching in the outer part of the galaxy, we would expect the H delta have a positive gradient. In other words, if the H delta is decreasing in large radius for centrally concentrated galaxy in the outer part, it won't have a sudden increase in H delta due to the fast quenching. So from the bottom row with the plot, H delta gradient for the centrally concentrated galaxies in high halo mass group points to slow quenching. But for clusters, we see some positive gradient which suggests a fast quenching. To quantify this, we need to take comparison to the stellar population models, and I'm still working on that. Here is my conclusion and my future work. My conclusion is the star formation becomes more concentrated from the field to groups and cluster. High mass groups show this signature, but not as strongly as clusters. Galaxies that have centrally concentrated star formation in groups and clusters have rather J-I color, which is an evidence of an aging population. H delta and DN4000 can be used to look at the timing of the quenching. H delta gradient in centrally concentrated galaxies in group point to slow quenching, but for clusters, we see some positive gradient which suggests the fast quenching. And my future work is to use stellar population models to quantify the quenching timescale and to compare the star formation history with simulations. That's all, thank you. And I'm happy to take any questions.
Okay, thank you, Dee. So I'm just going to have a look at if there were any questions in the Q&A. I don't see any at the moment. So I encourage...
I see one.
Oh, you see one, excellent. So mine has already disappeared. So please go ahead and read the question for us and answer it.
Yeah, does H delta DN4000 correlate with the presence of IAGN? Yes, it will, but not here in my sample yet. So I'm just comparing the star formation for these ones, but I think I will add in the AGN and liner-like galaxies in our sample.
Okay, thank you again, Dee.